my given name is I-Ching, as family name is, and the corporate Chih-Ming Lin. Okay, here we're talking about the beginning height, so we first define what the beginning height we used as the first emit visible light, because we use the data, we use the meteor shower, use the camera to catch the meteor. Okay, we know the beginning height is governed by 3 sets of parameters by the previous article. The one is the meteoroid properties. Second is atmospheric condition. The 3 is original velocity. We have studied the QA, TR, and the GM, and get the beginning height distribution. It's symmetry and the central tendency, and will be published. So here our purpose is we want to underline factor information the beginning height distribution. We important is want to know the distribution, and our question is the beginning height governed by the composition of the meteoroid. So we compare ORI and ETA is Halley origin, and the STA and NTA is Encke origin, and the mean is about the distribution can be explained. We can explain the mean value of the meteor shower. Okay. The data we used is download from the IAU MDC SonotaCo, and the period is 2008 and 2022, about 15 years. How to get to the distribution? We partition into 3 classes, and the mean value is here. Is this the mean value, and the class interval was divided as half of the standard deviation. So we can get the 11 class. Now this curve is fit Gaussian distribution. We want to get the mu and the alpha. From the low data, we can get an S bar and the sigma. So we want to compare X and the mu, the sigma and the alpha, the difference. And the statistical measure is skewness G1 and the kurtosis G2 to check the Gaussian distribution. Then we get the ORI of the data and show in the figures. 15 years. This ETA, and this is the beginning height, and this probability here. It's very it's in the 2 meteor showers also symmetry and the central tendency. Here's Encke origin shower, STA and NTA is also, this is the beginning height, and this is also the probability, and all figures in here. Next, this is the data. This is the mean and the 15. This mean and from this S bar and the sigma is from the low data, and the mu and the alpha from the fitting. It's very close. The value is very close in the mean, and the standard deviation a little difference. You can see. This is ORI and the ETA. This is left side is ORI, right side is NTA. It's very close, and the ORI and the ETA is very close, and it's very close. The beginning height is very close. So the next is origin shower meteor. This is NTA, and this left right is STA. This S bar mean value from the low data, and the standard derivative from the low data. And we also can find the value is very close, about 94. And in the ORI is 111, 110. Okay. So this is want to check the Gaussian normal distribution. And this way is very symmetry. From the G1, you can see it's smaller than the 1.
More minutes, 2.
G1.
Sorry, 2 minutes left.
Oh, okay. Thank you. The G1 is very close, smaller than the 1 and the minus, between the 1 and the -1, so it's very symmetry. But the G2 is larger than the 1, so not approach. We can say approach, not a consistent Gaussian distribution. Okay, so we can find the beginning height is the same for the Halley origin shower is this value, and the for Encke origin shower is this value. But the origin velocity is also the same, so we can find this. And this is the beginning height, the 15 years value, average of the 15 evasion value. So ORI and the ETA are very close. The beginning height is very close, and the velocity is also very close. So it's possible the value, the beginning height is same maybe because of the origin velocity. Okay. The second we want to discuss is the distribution shape, almostly Gaussian. Okay. The ORI is we can see a near symmetry, and the ETA is largely symmetry distribution, and the NTA and STA is meteor symmetry. Okay. So the conclusion is we talking about the determine the three set of parameters determine the origin beginning height, meteoroid matter purpose, and atoms of condition, but it's ignorable, and the origin velocity. So these two parameters may be determined at the beginning height, and the three-set parameter determine the distribution. Atoms of conditions ignorable, and the origin velocity ignorable because they can explain the distribution. Only the meteoroid material properties in the 1903 paper article the spectral evidence suppose the near Gaussian competition distribution. So in this talk,
I'm sorry, your time is over. I tried to let you finish. So okay, perfect. It was the very last slide. Okay, so thank you very much.